All right, I'm going to get started here today. Last week, when we left off on Thursday, we were talking about our limit laws that we came up with. Um, I gave you those limit laws last week, and we're just starting from there today. So this is our first example using our limit laws, combining them, and I'll give you some time to write it down. So we're going to use the observations that the limit as x approaches c of k, which is just some number, and the limit of as x approaches c of x equals c. And then we're going to use those limits and plug it in. So when we look at this one, it seems a little more complicated because we have a lot going on top and then a lot going on bottom. But our limit laws told us that with sums and differences and when we divide, that we can just use our rules of sums and differences and break it down into smaller pieces. So that I'm taking the limit as x approaches c of the top part, one piece at a time. And then the same with the bottom. I'm doing the limit as x approaches c of x squared, and then the limit is x approaches c of 5. So now that I have this broken down, I can take the limit of each one individually. So the limit is x approaches c of x to the fourth. There's nothing to worry about there. C is just a number that we're getting close to. So that would become c to the fourth. The limit is x approaches c of x squared. Same thing, is c squared. Whatever this number would be, we're squaring it. And then the limit is x approaches c of 1. There's no x here, so no c goes in. This is just minus 1. On the bottom, we substitute the c in for the x. It becomes c squared, and then plus 5. Because again, there's no x for c to plug into. So that's our final answer. Now, a little later today, we're going to actually plug a number in and show how this works whenever we get to the actual numbers. Okay, again, the top part is the same. You don't have to rewrite that. We're only rewriting our new example here. And now you can see my limit is as x is approaching negative 2. It's not a c anymore. They're saying that we have an actual number that x is getting close to. So again, this one looks like it's a little more complicated because we have the square root. But again, we can just do pieces again. So I'm going to do the square root of the limit as x approaches negative 2 of 4x squared minus the limit as x approaches negative 2 of 3. So first I need to figure out, is there anything that would limit my limit? Wow, that was probably a poor choice of words. Is there anything that would mess up my limit? That's a better way of saying it. Mess up my limit if I plugged it in. It's just the -2. So if I plug the -2 in for this first piece of this, it would be 4 times -2 squared. Now that's not going to give me a negative or anything that would mess it up under the square root. So it's okay to just plug this -2 in for x. For the second piece of this, is there an x in this portion? No. So it stays as 3. Because I don't need to plug my -2 in for anything. And I would just solve. -2 squared is 4. So this is 4 times 4 minus 3. It gives me the square root of 13. And that's all there is. I don't want you to break this down into some decimal form. Just leave it as the square root of 13. It's best to be seen that way. Okay, so now we're going to get into some more theorems. The first one says that the limits of polynomials can be found by substitution. This means that if I just have some basic polynomial like, say, 5x to the 5th plus 3x to the 4th plus 2x to the 3rd, down to whatever, then all I have to do is substitute in exactly the same way as I did the last problem. So if I'm finding the limit as x approaches c of that polynomial, you'll notice all it does is it plugs c in everywhere there's an x. Anytime I just have a polynomial, I can use substitution. Theorem 3 says that if we have rational functions, which means one polynomial over another one, then we can find the limits by substitution if the limit of the denominator is not 0. Very important that the bottom polynomial, if we plug the number in, it can't be equal to 0. So we can just use substitution as long as it's not equal to 0. So if you remember, we did this problem earlier where we just had a c. And so now if I look at this as I plug in a -1, the first thing we'll check is, and I'll let you write it down, but the first thing that we'll check is making sure that the denominator would not equal 0 if I plug the -1 in. So when I start this problem, I'm going to do the limit as x approaches -1 of, and then I can do the limit of each part separately. So now if I try to substitute into the bottom first, that's putting a negative 1 in for x squared. So that would be negative 1 squared plus, and then over here, there's nothing to put an x in for, so that just stays 5. I'm going to check first to see if this gives me a 0 in the denominator. Negative 1 squared is 1, plus 5 is 6. So since there's no 0 in the denominator, I can just plug in. Now if I go to the top, negative 1 to the third plus 4 times negative 1 squared minus 3. Negative 1 to the third stays negative 1. Negative 1 squared is 1. 1 times 4 is 4. So it's negative 1 plus 4, and then minus 3. That gives me 0. So 0 over 6 is just 0. I am allowed to have a 0 in my numerator, but just not the denominator. So my limit as x approaches negative 1 of this whole thing is equal to 0. If I look at the new example that I just put up, the first thing I'm going to look at is my denominator. And I'm not going to write out the limit as x approaches 1 of each one of these. I'm just going to look at my denominator. If I was to substitute 1 squared minus 1, 1 squared is 1, minus 1 is 0. So that would give me a 0 in the denominator, which means I can't just substitute in. So since I can't substitute in, it tells me I have to do something else before I can move on. So when I look at this one, I have a polynomial in the top and a polynomial in the bottom. So I can't just substitute here. So what I'm going to do is I'm going to look at the top and see if I can factor that top out. So if I'm looking at the top, x squared plus x minus 2. What will that factor out to? I know x times x gives me x squared, right? And then I have to look at what multiplies to give me negative 2 and adds to 1. Well, the only things that multiply to give me negative 2 would be 2 and negative 1, or negative 2 and 1. 2 plus negative 1 gives me 1, so that's what I'm looking for. So it's going to be x plus 2 and x minus 1. In my denominator, can I factor anything out of the bottom? Both terms have an x, right? So I can pull an x out in front. That's going to leave me with x times x minus 1. And now when I look at this, I have x minus 1 in the top and x minus 1 in the bottom. So I have a common factor that I can cancel out. Now that leaves me with the limit as x approaches 1 of x plus 2 over x. Now if I try to plug a 1 in to the denominator, that gives me a 1. And so I'm allowed to do that because I didn't end up with a 0. So I can do the limit as x approaches 1, x plus the limit as x approaches 1 of 2 over the limit as x approaches 1 of x. Now I'm just going to plug that in. So the limit as x approaches 1 of x is just 1. The limit as x approaches 1 of 2 just remains 2. And the limit as x approaches 1 of x is also 1. This gives me 1 and exactly 3 over 1, which is just